So let's start with a review then of quadratic functions. So quadratic functions. Right. So let's start with finding the other stuff. I'll give you one equation. So for your warm-up, I want you guys, this is your equation. And I want you guys to find the y-intercept. Sorry. Oh, that's x. Sorry. There. X-intercept. And then vertex. And we'll expand on domain and range a little more, but I want you guys to give it a shot. So here's your equation. Give it a shot. And if something doesn't make sense, don't worry. We'll go over it and I'll do the example problem right now. Okay, but you guys take like 4 or 5 minutes for the equation and try finding all this. the fourth one of domain. Yeah, so that's like how much your x values are. Do you get the answers for all of them? Okay, can you put it in the chat? And then we'll review those. Yeah. Remember the vertex is in between the two x-intercepts. That's my hint for you. Mm-hmm. Okay. Tell me what you got. Okay. What did you get for x? Mm-hmm. Okay. And then the vertex. Mm-hmm. 91. Okay. Okay. Infinity, comma infinity. Okay, and then range. Okay, so we need some. Okay, so I'm pretty sure for this one, on Dorsey, I think you got everything right. But for this one, I think the x-intercepts are supposed to be negative, right? So let me try solving this, okay? Let's start off with the y-intercept, which is just f of 0 equals okay, we're all good with this, right? We're all good with the y-intercept. X-intercept, I think we had some confusion. So what adds to let's see, what adds to 6, multiplies to 6 and then adds to 3, 5, sorry, adds to 5, right? So you said 3 and 2, right? So we do plus 3, plus 2, right? You're good so far? But this would mean our points are negative 3, 0 and negative 2, 0. Does that make sense? Because remember, this is just like saying x plus 2 equals 0. And if you want to get x alone, we have to do minus 2, which means x is equal to negative 2. Are we clear on that? I just want to make sure, you know? And then remember, vertex is always the middle. So in this case, it'd be this. And to find a y value, we'd use the original equation, which is f of negative 2.5 equals 2.5 squared plus between negative 3 and negative 2. But then that'd be 0.5 close to negative 3 and 1.5 away. Right? If you have negative 2, you have negative 3, negative 3.5 would be right here, right? We want something right here. Does that make sense? Yeah? Okay. So that'd be like further away from 0, and it'd be closer to negative 3, but it wouldn't be closer to negative 2, so we can't say it's the middle. Right? Okay, now if you try solving this one, this should be f of negative 2.5 equals 6. Remember, even though there's a negative there, since it's being squared, it turns into a positive. Okay, and then we do 5 times negative 2.5, which should give us, that should be a negative sign, negative 11.25, and we just drop our 6 down. Are we good so far? Dowarski, any questions? Oh, well, no. Okay, So now that we got this, we could just add it all together. So what I like to do is I look at this one and I look at this one. Then we could just do f of negative 2.5 equals 12.25 minus 11.25. So f of 2.5 equal 1? No. Wait a second. Let me plug it into my calculator. This. It should be point. Darcy, do you see where I made a mistake? Oh, that, yeah. Okay, yeah, I see it. Okay, where's the eraser? Let's do this. Yeah, okay. So this, should be 12.5. It's 12.5, right? So this just becomes, 12.25 minus 12.5, which makes this negative 0.25. Okay, are we clear on that? Yeah, okay. And for domain and range, I like to graph it. So if we had a graph like this, I know one of them is at -3, one of them is at -2. My vertex is somewhere right here because it's -2.5. Okay, let me do it in proper notation. That is -2.5, -0.25, right? Because it's below y equals 0. So my graph would look something like this, right? And it keeps going up and up. And remember, as a graph goes up, the domain, the x values are getting bigger and bigger, right? So that tells me that the x values are always increasing to be negative infinity to infinity, right? Does this make sense? We wouldn't say infinity to infinity because that's like saying from point B to point B, right? If you want to go somewhere, you have to start at a negative distance or some other number, right? And remember, we always do lowest to highest. So in this case, the lowest y value for the range would be negative 0.25, and the highest is infinity, right? Because it keeps going up and up. Does that make sense? Okay. So this should have been warm up. We still need practice with domain and range, but I'll incorporate that into today's lesson as well. So a lot of times we just do this, but there's many instances where quadratic functions aren't really, they're not as nice, where you could just use a times b, a times c, and then adds to b, right? For example, there's quadratic functions like, let's say you have x squared plus x plus 1. You can't really use the FOIL method, right? You're like x if you do this, you're like, okay, it multiplies to 1, and then adds to 1, which doesn't really make sense, right? So you really wouldn't be able to do this one, right? It's impossible using this method. So we have something what's called a quadratic function. Quadratic formula, sorry. So we have something called a quadratic formula. And it's a really key formula for, let's say if you have a graph, like you have something like this on the test, and if you don't have enough time to really like do it quickly, or you think there's no like clean factors like a whole number, then we would move on to the quadratic formula. Remember, we could only use this when we have nice integers. Right, we could only use this when we have like 1, 2, 3, or whatever. So that's why we have the quadratic formula, which basically just states that our x-intercepts are equal to negative b plus minus b squared minus 4ac all over 2a. And how many of you guys are familiar with this? Does anybody know this formula? You don't really know this formula? Okay. Okay, yeah, that's okay. We're here to learn. So, it's probably better that you don't know, so I can teach it to you. Okay, so let's look at our original equation, which was x squared plus x plus 1. I want you guys to identify the b, a, and c value. So b, a, b, and c values. Do you guys know what the a, b, and c values are? But remember, we can only put numbers. So what's in front of the x squared? Well, the 2 is above the x squared. What's in front of it? What's the coefficient? Yeah. Remember, if there's no number, there's always an imaginary one, right? If there's no number in front of it, yeah, it would be 1. Because 1 times x squared is still x squared, remember? But if you have 0 times x squared, then that becomes 0. And then 2 times x squared doubles the value, right? So if we just have x squared, we could put a 1 and 1. And then this is your a, this is your b, this is your c. Remember? A times c adds to b. So then your a would be 1, your b would be 1, and your c would also be 1. Okay, are we good so far? Does this make sense? Yeah? Okay. So you have to memorize this. Memorize this formula. Remember, this plus minus means 2 intercepts. So we can signify as 2 intercepts. And then we could just plug in our values, right? So x equals negative, what's our b value? We said 1, right? Plus minus square root, we have b, we said that's 1 squared, minus 4, what's our a value? We said 1, C value, we said 1. Then you could put that all over 2. What's our A value? 1, right? So then x just becomes -1 plus minus 1 squared is just 1 minus 4. 4 times 1 times 4 is just 4, right? And then this all over 2, because 2 times 1 is just 2. Are we good so far? Does this make sense? Yeah? Okay. So, now that we plugged in all our numbers, our next step will be, since we already put in our numbers and condensed it, our next step would be to solve it, right? Well, first of all, does anybody know about the discriminant rule? Does anybody know what the discriminant rule is? Discriminant. Yeah. It's whatever value, it's whatever number, are b squared minus 4ac equals, right? This is another thing to memorize. If this number is less than 0, if this is less than 0, then this thing has no x-intercepts, right? So if it's a negative, if this gives us a negative number, let's say this gives us -4 or -3, then there's no x-intercepts, right? Because we can't square root a negative number. Is that clear so far? That's clear? Okay. And then there's 2 more. There's if the number is greater than 0, then there's 2 intercepts, right? Oh, by the way, this would be no real, because they're still imaginary, but you don't have to know that right now. There's no real x-intercepts, right? And then there's this, and then there's one more, which is if the number is equal to 0, there's 1 intercept. Okay, and one easy way to remember this is if the number is less than 0, in the real world, you don't say I have negative, I have negative hours to do this homework assignment, or I have negative hours to study. That's not a real thing. So we could just say no x values are real here because it's negative. You can't have less than 0 x values. More than 0 means you have more than 0. You have a definitive number of intercepts. So we could say, yeah, there's 2 intercepts. And if it's equal to 0, I like to think of it like it's on the line, right? So it only touches the intercept once. Yeah. No, I'm not talking about time. I'm talking about the assignment. I'm talking about the assignment stuff. There's, when you say, oh, I have 2 homeworks to complete, but if it's negative, you wouldn't say I have -2 homeworks to finish, right? Right? Yeah. because you have to have a number of stuff to do, but if the x is less than 0, then there's, no intercept. They don't exist. And then equal to 0 is always there's one intercept, because it touches the line at y equals 0. Does that make sense? Yeah? So in this case, what would our thing be? Okay, so you said it would be x equals -1 plus minus -3 or 2. But what about now? Look at our discriminant. What does our discriminant tell us, guys? Right, yeah, because this thing is a negative number, therefore no real x-intercepts. Right, are we clear on that? Okay, so IT, you're good on that too? Okay. No questions, no nothing. If you guys don't have questions, we will go through one more, right? And then I'll give you some to work on. Does that sound good? Yeah. Class ends at 10 o'clock. Do you have to go somewhere? Okay, yeah. So, you guys fully understand the discriminant rule, right? Is it all clear? Okay. So, I'll give you one other problem. 5x squared minus 6x plus 1. And I'll solve this one because I want you guys to see what would happen when we actually have to solve it, right? In your steps, always start off with the discriminant. Always start off with d, for d is the discriminant, right? And then d is equal to square root of b squared minus 4ac. Plug in our values. D is equal to, remember a, b, c. What is b? -6. -6 squared becomes 36 minus 4, and a is 5, and c is 1. So this becomes b is equal to 36 minus 20, which is b is equal to 16. This is a positive number. So how many x values do we have then? Oops, this should be a D. Take a guess, guys. How many x-intercepts do we have? My voice is breaking. Is this better? Okay, I'm just asking. So, do you see what I did on the board? Okay, do you see how we got a positive number for the discriminant? So I'm asking how many x values do you think we have since it's a positive discriminant? We wouldn't have 16 x values, right? Let's look back at the rules, okay? Here. So which one does 16 fall under? Sixteen is equal to 0. Because square root of 16 is 4, and 4 is greater than 0, right? So we would have 2 intercepts then. Because it's a positive number, so, positive number means you have a real amount of something, so that'd be 2. So 2 real solutions, right? Does that make sense? Are you guys clear on that? How we have 2 real solutions? Right? Okay, now that we know that we have real solutions, let's try actually solving it. So when we solve it, it becomes x equals negative b plus minus b squared minus 4ac all over 2a. So let's substitute our values in. So we said b was negative 6. So it becomes negative 6 squared plus minus, we said negative 6 was our thing. Oh, oops. This should not be squared. If you guys have any questions, tell me and I'll answer it. Okay, and then our b value is also negative 6. Okay, well, we don't have to solve the discriminant again, right? Because we already solved it when we tried finding discriminant. So we know that it's equal to 16. And then over 2. And then our a value, which is 5. Are you guys clear how we got here so far? Yeah? Okay. So if we solve this further, we get s is equal to, this should not be a squared. I don't know. Okay. There. And then negative 6 times negative, a negative number times a negative is positive, so that just becomes 6. Plus minus, and then square root of 16 is 4, because this breaks into Hey Amruta, we are just learning about the quadratic formula and how to find the x-intercepts using them. Okay, do you know how to do it, or do you want me to give another example problem? Okay, so we're doing one right now. So do you know what the discriminant rule is? The discriminant rule. No? Okay. So the quadratic formula is, this is a quadratic formula. X is equal to negative b plus minus square root of b squared minus 4ac over 2a, right? So our discriminant is basically this entire thing. This is our discriminant, the square root of b squared minus 4ac. So when our square root of b squared minus 4ac is less than 0, there's no real x-intercepts. And when it's greater than 0, there's 2 x-intercepts. And when there's, equal to 0, there's only 1 intercept. Are you clear on that? Yeah? Okay. think of it like if it's less than 0, then you have negative homework assignments to do, which doesn't exist. You can't do negative homework assignments. If you have more than 0, you have like multiple homework assignments. You could have 2 or 3. If it's equal to 0, there's only 1 you have to do, right? To get it to 0, you're 1 away. So back to our thing. So we found the discriminant has, so we're doing a problem that's 5x squared minus 6x plus 1. So after doing that, we got the discriminant has square root of 16, which is a positive number. So that goes into the second rule, because 4 is greater than 0. 2 intercepts. So then we do this plus minus 4 over, over 10, right? So then x would equal so we have 6 plus 3 and 4, so it'd be 6, which is just 3 over 5 plus minus 2 over 5, right? So our x-intercepts could be 5 over 5, or it could be 1 over 5. Does that make sense? Yeah. So AT Dworsky, does that make sense? Okay. So if there's no questions, I'll give you guys a problem to do. So there's no questions, right? Everyone's clear? Yeah. Okay. The formula? Yeah, I'll write the formula again. So I'll give you guys 2 problems though. So our first problem would be 2x squared plus 5x plus 7. And then our second one would be let's see. Let's do yeah, okay, let's do the same thing. 2x squared plus 5x plus 2. Okay, and then here is your formula, which is the x-intercepts are equal to negative b plus minus b squared minus 4ac over 2a. Okay, so formula, there's your formula. Here's 2 problems, and I want you to find the x-intercepts for both of them. And if they don't exist, explain why. Okay, did everybody hear that? Got it? Okay, awesome. So this should take you like, I'll say 10 minutes for both of the problems. Okay, good luck. If you have questions, feel free to ask me. Oh yeah. Here, I think that should get everything. There, so they're up on the far right. Do you see everything or? Okay, okay. If it's difficult to see or you need to zoom in, let me know. Okay, awesome. Okay. M for man. Oh, that we could go M for M. Yeah, okay. So I think this might be the last problem they end class with. Okay, let's give like 2-3 minutes for everyone else, okay? Did you do both of them? Okay, put your answer in the chat. Yeah, I'll explain the whole thing. Don't worry. Okay, how much time do you guys need? Amruta, how are you doing? Yeah, take your time, no worries. I just want to get a rough estimate because class is about to end soon, right? Yeah, this is our last problem. This is like your exit slip. Second one? Okay. I'll give you guys 2 more minutes. How about that? Okay, yeah, no worries. I'll explain it. Okay, how are we doing on time? Everyone. Okay. Yeah, no worries. And what about you, Saiti? Oh, sorry, did you find your mistake? Okay, I think she's working, so I'll let her be. Okay. Okay, I'm done. Yeah, you could go to our ski. Okay, Amrita, whatever you got, put it in the chat and I'll check it. In the chat, the Google Meet chat. Swati, how much more time do you need? Okay, you want me to explain it? So, are you okay that we start solving it now? Okay. You got the first one? What did you get for the first one? Okay, yeah. And I'm sure everyone else did the same. Amrita, what did you get? For the first one? Okay. Okay. What did you get for the first one, though? you have the same answer for both? Okay, well, let's talk it through because these have two different numbers. This one has a 2 and that one has a 7. So remember, whenever you solve questions, always start off with the discriminant. What is the discriminant? Well, it's just b squared minus 4ac. So let's plug in our values then. If this is our a, this is our b, and this is our c, then let's look at it. So what is b? 5. 5 squared minus 4. What is a? A is 2. And then what is c? C is 7. So let's do it. D equals 5 squared is just 25 minus 4 times 7. That would just give us 28 times 2, 56. So D is overall a negative number, right? Can we agree on that? Yeah? So if D is a negative number, looking back at our rules, which discriminant rule does this fit into? Negative number is less than 0. So it'd be this one, right? Which means that there's no x-intercepts. So we could just write no real x-intercepts. Oops. Is this clear for everyone? Yeah? Okay. Amrita, do you understand why we can't get x-intercepts for this one? Yeah, here. And we'll do more with this next class as well. This class was more like a review for it. Not a review, like more like an intro for this. Oh. Yeah, I'm gonna explain the second problem and then I'll end class. Yeah, if you have to go somewhere or something, you are free to go though. Okay, yeah, I'll explain this really. Yeah, it'll be at a video. Okay. Bye. Alright, let me know. You're done. Okay, so let's do the second one. So D is equal to, remember, discriminant is b squared minus 4ac. So let's label them A, B, C. Okay, so now we know what our A, B, C values are. So then D is equal to square root, what is B? 5 squared minus 4, what is A? That's 2. C is also 2. So then D is equal to 5 squared, which is 25, minus 4 times 2, which is 8, and 8 times 2, which is 16. So then D is equal to 9, right? Can we agree on that? Okay, so discriminant is a positive number, right? It's a positive number. Amazing. But that one falls into this one. It's greater than 0. So we know there's 2 x-intercepts, right? And we know square root of 9 is just square root of 9 is just square root of 3 times 3, right? So we could take out a 3. Square root of 9 is just 3. So we know that the inside is 3, but we still have, so we don't have x equals negative b plus minus, well, we said this was 3, right, over 2a. So then x is equal to, what is our b value? Negative, it's 5, so it becomes negative 5 plus minus 3 over 2, which our a value, it's also 2, So this would just become 4. So then our x is equal to negative 5 over 4 plus minus 3 over 4. So what does that tell us? Our x is going to be either negative 2 over 4 or negative 8 over 4, which simplifies to negative 1 over 2 or negative 2. Is that clear? Yeah? Okay, so I'll send a video recording of this, and I'll link it in the group chat. If you have any questions, please talk to me about it. We're gonna do more of this next class, don't worry about it. But if that makes sense, I think that's where we'll conclude class. So, goodbye, guys. Alright, take care.